So hi everyone, you can see this is the kit for flip-flop using NAND gates and TTl ICs. So in this experiment, using this kit we can verify different types of flip-flops. So first we should know what is flip-flop. A flip-flop is an electronic circuit that has two stable states, one representing a binary, one here, and another representing a binary 0. So it has two stable states, 1 or 0. The name comes from its ability to flip or flop between two stable states. Here you can see on this apparatus there are different types of flip-flops on its performance. So first one, that is RS and D flip-flop. The circuit diagram has been given on this apparatus. You can make the connections according to that. And this is JK flip-flop and D type flip-flop. So we have to verify all these different types of flip-flop. First we can go for RS and D type flip-flop. I have already made the connections here, you can see. So first you should know the circuit diagram. Already it is on this device. So here I am going to show you. So this is what the circuit diagram, S and R. And then truth table is here. So according to this truth table we have to verify the output. So first I will explain you here the circuit connection. So here is the inputs, preset and clear. You should connect to these inputs. So here I have connected to the input and then these to the this one clear to the input, and then S and D are what S or D or R. These are outputs, so you should connect it to the binary numbers. Then here is the output Q and Q bar. So I have connected to the output. Then this is the clock. So here is the clock. I have connected to the clock. So power supply output must be grounded. Then next what we have to do, so first we should switch on the device. Then so here in this tabular column, the first preset is low, clear is high, and you should not apply clock here, and this S and R also should not apply. Q should be high and L should be low. So what I will do, I will apply preset low. Here is the preset, you can see it is low, 0, high that is clear. So clear is high, here is the clear. So I am going to apply here high. Clear is high, preset is low, and the output must be what? Q must be high, Q bar must be low. So according to this we have verified this first one. Next go for the preset should be high and clear should be low, and clock S and R should not be applied. The output must be reversed. So let us this clear must be low and preset must be high. So output you must get here opposite of that Q must be low and Q bar must be high. So this is also verified. So next both should be low, okay, clear and preset must be low. We should not apply clock. All here the output we must get both should be high. Both should be high. Both should be high, preset and clear, and we should give one clock pulse, and S and R must be low. So the output must be as it is Q bar. So let us verify here. So both should be high, preset high, clear high, and we should give one clock pulse. So the output must be Q and Q bar. Q must be high, Q bar opposite to the Q, that is low. So next one, in all these verification, preset clear must be high. We should apply each time one pulse, clock pulse, and then S here, S is going to vary. S is high, R is low, and then Q bar must be high and low. So let us verify here. So one clock pulse again, and then S must be high, S is here, S is here, high, R must be low, so the output must be high and low, correct. Q must be high, Q bar must be low. So next one, only we have to apply each time one pulse, and we should change S and R input. So here this time S is low, S is low, this R is high, and we should apply one clock pulse. You can see output has been changed here for this one. Output Q is low, Q bar high. So Q is low, Q bar high. So like that you should verify the truth table for different types of flip-flop. If we apply all the values high, input and SR values high, and we should give one clock pulse here, clock pulse, and make it high. So output, this should not be actually used. So this is what we have verified, RS flip-flop. Next we go for another flip-flop. So we can go for another flip-flop. Before that I will make all them value low, and then switch off the device. And here the next one is RS and D type. Here we should connect this NOT gate across this S input, and then we can verify the another truth table within this circuit diagram. So let us connect this NOT gate. So here S or D type flip-flop, we can make the connection according to the given circuit diagram. Here we have to connect the output of the NOT gate to the input of the R. So once we connect, it acts as D type flip-flop. Let us verify. So here I have connected the preset input and the clear, that as input, and D, if you want to make, connect this output of the NOT gate to the input of R. So I have connected here. So let us verify. Here is the clock. So this is the truth table. Input preset low, clear high, clock we should not apply, and D should not be applied, and then Q and Q bar must be verified, high and low. So here this S is nothing but what, input for D. So this is input. So preset low. So this is the preset low, and this clear must be high. Then D must be low. The output must be verified here. So output is what here? Q must be high, Q bar must be low. So next one, preset high, clear low, preset high, clear low, and we should not apply clock or D input. This must be opposite. The output must be, Q must be low, Q bar must be high. You can see Q must be low, Q bar must be high. So the next one, both should be low, preset clear and clock we should not apply, and D must be low. Our output must be high. So both should be high. So you can see due to some loose connection, it is not blinking. So both should be high. Here preset clear must be high. We should apply one clock pulse and then D must be high. Here the output Q must be high and Q bar must be low. So let us do this. So both must be high. We should apply here one clock pulse and then D must be high. So output must be what? Q must be high, Q bar must be low. So this is also verified. Next we go for both preset and clear must be high, one clock pulse, D must be low and output should be reverse. So first we should apply one clock pulse, D must be low and output we should get here the Q must be low, Q bar must be high. So this is how we can verify the S or D type flip-flop.